This video is to introduce the basic concepts of beam deflection. Here, we will only introduce a beam would deflect with different supports and loadings. We will not go into the detailed calculation. In the following examples, we assume that the beam has no weight and the deflection is enlarged many times when compared to the actual deflection. Example 1. First, we have a beam with a fixed support and a point load acts at the right end. Then, the beam will deflect downward. The distance between the deflected position and the original position is defined as deflection. It is very important to understand that at the fixed support, the beam does not have any deflection, and the tangent to the deflected beam at this point is horizontal. In other words, the slope of the tangent is 0. For the points near the support, the deflection and slope are relatively small, but when the point is closer to the point load, the deflection and the slope increase. Example 2. The second example is a beam with a pin or roller support at the end and a point load at the middle of the span. In this case, it is easy to see that the maximum deflection will at the middle of the span. At the supports, no matter it is pin support or roller support, there is no deflection, but the tangent to the supports are not horizontal. That means the slope of tangent at the supports are non-zero. If the single point load is changed to a distributed load, the maximum deflection will still be at the middle. The deflected shape of the beam is very similar to that due to a single point load. Example 3. The third example is a beam with two supports and a free end. We have 3 steps to sketch the deflected shape of the beam. First, the deflection will occur around the point load. Second, there is no deflection at the supports. Finally, for the free end, as we assume the beam has no weight, the right part of the beam, BC, does not bend and will remain straight. The slope of this part is the same as the slope of tangent to the deflected beam at the right roller support B. However, if the free end is connected to another roller support, C, as shown in this figure, the right section of the beam BC needs to bend downward in order to maintain zero deflection at the support C. That cause the right section of the beam will bend upward, then bend down to the support. Next, we further extend the beam so that the third part of the beam, CD, has a free end at D. By applying the same load on AB, the deflected shape from A to C would be similar to the previous case, except that the part CD remains straight and has no bending. Example 4. In this fourth example, the beam has a fixed support at the left end and a roller support at the right end. First, at the fixed support, it has no deflection and the slope is 0. Close to the fixed support, the beam concave downward like an inverted U shape. But, further away from the fixed support, the beam concave upward again, like a U shape, until it reaches the right support. Example 5. In this last example, the beam has 2 fixed supports. The deflected shape will be symmetrical about the center. At both ends, the deflection and slope are 0. Then, gradually, the beam change from concave downward to concave upward, like a U-shaped curve, at the middle. By sketching deflected shape of a beam, it would help us to better understand how bending moment varies along the beam.